Okay, so we're going to take a look at concavity. Function can either be concave up or concave down. So if we look at both of these graphs, as we're moving left to right, the graph that is concave up, the derivative of this graph is always going to be increasing. And then the derivative of this graph is always decreasing. Okay. So therefore we know that since this, if f prime of x is increasing, think about taking the derivative of a value that's increasing, f prime of x increasing. We'll find that f double prime of x is positive. And then concave down, we're going to find that f double prime of x is negative. So we can use this information to analyze a function, the concavity of a function. So the first thing you're going to do is find the critical points of f double prime of x, and then you're going to check the sign of f double prime of x on each side of the interval. So what this means is that, let's say you find that you have a critical point at 0, f double prime of x is equal to 0 when x equals 0. Okay, so you'd use a value, let's say -1, that's less than 0, and a value that's greater than 0. Plug that into f double prime of x, and then you would find, let's say that you plug that in, you plug -1 in, you get a positive value. You plug 1 in, you get a negative value. And then going back to this, we know that it is concave up when f double prime of x is positive. So we know here now that this is concave up and negative, so this would be concave down. So we'll take a look at a few problems. F of x is equal to x squared minus x. So we would find f prime of x is equal to 2x minus 1, and then we find f double prime of x to equal 2. So we know that this is always concave up, because f double prime of x is always positive. Okay, so look at a harder problem where f of x is equal to 3x to the 4th minus 4x to the 3rd. Again, we find f prime of x, which is equal to 12x to the 3rd minus 12x squared. And we find f double prime of x, which is equal to 36x squared minus 24x. And then we find the critical points of f double prime of x. So that's where this function equals 0. So we can take out a 6x here, 12x. We can take out a 12x. We'd get 3x minus 2. And then we find where this function equals 0. So we know if we plug in 0 to this, well, it would be 0 times -2, so it would be 0. So we know a critical point is at 0, and then we also know a critical point is at x equals 2 over 3. 2 over 3. So then we'll examine these values. So we'll draw a little diagram, whatever here, with 0 and 2 over 3. we'll assess a number here. Let's say -1. We'll get 3. Oh, here. We're plugging it into f double prime of x. 36 plus 24. So this is positive. Let's plug in a half. We're going to get 30. What? It's going to be negative. And let's plug in 1. 36 minus 24 is positive. So therefore, using this information, we know that when it is positive, it is concave up, negative is concave down, positive concave up. So we can write that it's concave up and concave down. So concave up on the interval of negative infinity to 0, and 2/3 to infinity, and concave down from 0 to 2/3. Let's take a look at another problem. Let's say f of x is equal to negative x to the third plus 3x plus 2. So we'll find f prime of x, which is equal to negative 3x squared plus 3, and then f double prime of x, which is equal to negative 6x. So we know our critical value is x equals 0, and we'll evaluate -1 would be a positive, and 1 would be a negative value, concave up, concave down, and then you know the intervals. Using this information, we can also evaluate the inflection points. So the inflection points. Okay, so the inflection points are going to be where the concavity changes, whether it's increasing to decreasing or decreasing to increasing. So we'll do the same exact thing. Let's say f prime of x is equal to 1/2 x to the fourth minus 4x to the third. And then f prime of x is equal to 2x to the third minus 12x squared. F double prime of x is equal to 6x squared minus 24x. Okay, and then we find where this is equal to 0, so we can take a 6x out of there, we get x minus 4. We know critical points are 0 and 4. Okay, and then we'll evaluate for 0, 4. Plug in -1, you get 6 plus 24, positive. Plug in 1, you get 6 minus 24, negative. Let's plug in 5, you get a very large number, but it's going to be positive. So we know now that this is going to be concave up, and then it switches to being concave down at 0, and then it goes back to being concave up at 4. So our inflection points are at x equals 0 and 4, where the concavity changes. We can also use this to find the relative extrema. Okay, so to find the relative extrema, we can use the second derivative test, which basically says where f prime of c is equal to 0. So you're saying that the slope of this graph, f of x, is 0. And the second derivative of f of x exists on an open interval containing c, the value c. So if we think about this, f double prime of c greater than 0 would mean that we have a relative minimum. And if we find that f double prime of c is less than 0, we have a maximum. This goes back to what I said at the beginning, when we found that if f prime of x is increasing, it is concave up, and when it is decreasing, it is concave down. So if you look at these graphs, we would have a maximum here and a minimum here. So we can do a few problems finding inflection points. Let's say f of x is equal to x to the fourth minus 8x squared. You find f prime of x to be 4x to the third minus 16x. Find where this equals 0. We can take out a 4x. We get x squared minus 4. So we know at x equals 0, and then negative 2 and 2. So these are the points where f prime of x is equal to 0. 0, negative 2, and 2. And then we find the second derivative. So 12x squared minus 16. Plug these values in. Negative 2, 0, 2. Find that this equals 32, negative 16, and negative 32. So just by looking at these values, we know that it has minimum 0. Okay, so I did this wrong. This is not right. This is going to be negative 16 and negative 16. And when you plug in 0 up here, it's going to be 0. So now we can analyze these. We know that we have a maximum at x equals 0. And then our two minimums are negative 2 and 2. The graph would look something like this. Negative 2, 0, and 2.